Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to use sign charts to determine the positivity and negativity of functions and to find the products and quotients of functions. How are we learning it? Through the function sign charts notes and the function sign charts assignment. When can we use this information? To examine financial statements for businesses to determine times of profit and times of debt. How do you know you learned it? By getting a score of 4 on the function sign charts assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the function sign charts notes, and then I'll give you time to complete the function sign charts assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the reasoning with representations of function study guide and any incomplete assignments that you may have. Let's take a look now at the function sign charts notes. The notes begin with the learning goals and success criteria. Now, what is a function? A function is a relation in which each element of the domain is paired with exactly one element of the range. So that means that for every x, there's exactly one y that matches with that x value. If there is more than one y to match up with an x, then it is not a function. So let's look at some examples here. So we have a bunch of dots here. We have tables, we have equations. We can see it in various different ways. But if we notice here, there's an x value here at x equals -4, and y is -3. There's no other y value that matches with it. Same thing with all of these. Here we have a straight line. I can pick any x value, and there's only one y that matches it. Here, again, same thing. Now, non-functions look something like this. So notice, if I pick an x value like x equals 0, so when x is 0, y is this one, it's this one, and it's this one. So there's 3 different y values that match up. That doesn't work. Same thing here. If we look here at this x value right here, there's 2 values there for y that make it true. So that doesn't work. Same thing here. If I pick x equals 0 here and here, there is 2 points. So again, not a function. Now, what is a function value? A function value is the resulting range value, so the y value, after a given domain value is selected that makes the function true. So in order to find a function value, we're going to plug in the given value for x. So whatever they tell us they want for x, the function value is the result or the output. So for instance, if I have f of 3 is equal to x minus 5. So all that means is I'm going to take 3 and plug it in, and then the result is what we call the function value. So we plug 3 in for x, and we get 3 minus 5, which is -2. So -2 is my function value. So finding a function value from a graph. So which of the following letters represents f of 4? So I'm going to go here to where x is 4, which is here. So notice I have f of 4 is represented by this dotted line p here. So it's right there. And we would say then that p represents f of 4. Now, if it asks for the actual solution, then that would be c. So p is our answer in this one. Now, if it actually gives us the value, so 2, f of 2. So here we would say f of 2, which is right here, and x is actually 2. So that means that we're going to select the actual point on the graph, which in this case is D. So if you see something like this in coordinate form, you're going to find the actual point on the graph. If you see it and it's just this part, like f of 2, it's going to be the value on the dotted line, which would have been b. Now, how do we find a function value from an actual equation? So it says, what is the function value for f of 6 for the function f of x is equal to 2x minus 5? So what we're going to do is we're going to take f of x equals 2 minus 5, and we're going to plug 6 in for x. So it goes here and here. So f of 6 is equal to 2 times 6 minus 5. Well, 2 times 6 is 12. 12 minus 5 is 7. So the function value for f of 6 is 7. Now, how do we perform operations on function values? So let's say, given the table above, what is f of 2 minus g of 1? So what that means is we're going to find what f of 2 is and then subtract g of 1 from it. So f of 2, if we look at f of 2, we can see that the value here is negative 2. So when x is 2, y is negative 2. So we keep that there. And then we look at g. So g of 1, which is here, when g is 1, the g of x is negative 1/2. So we take those two values, and then we're just going to subtract them, just like it says. So f of 2 minus g of 1 is the same thing as negative 2 minus negative 0.5, which is really plus positive 0.5. And we get negative 1.5 as our solution. Let's look at another example. So this one says, what is 4 times h of negative 2? So if we take h, so when h is negative 2, y is 4. So there's our value. And then we want 4 times that. So 4h of negative 2 is the same thing as 4 times 4. And 4 times 4 is 16. Now let's look at another example. So it says, what is f plus g of 2? Well, when we write that out, f plus g of 2 is the same thing as f of 2 plus g of 2. So when we do that, we find f of 2, which is negative 2, and g of 2, which is 1. And then we're just going to add those two together. So we add up negative 2 plus 1, which is negative 1. So when we do this and you see f plus g or f minus g or anything like that, really what that's saying is we're going to take f of this value and then whatever operation's there and then g of that number. So let's see another example of this. This time we have fg of 8. Well, fg just means multiplication, so really we can break that up and it becomes f of 8 times g of 8. So f of 8 in this case is 40. And g of 8 is right here, which is 4. So now we just multiply these together and we get 40 times 4, which is 160. Now, what is a sign chart? A sign chart is used to determine on which intervals a polynomial function is positive or negative. So we talked about positive and negative intervals. Now we're going to use a graphical display to show where it's positive and where it's negative and when it changes between them. So the top of the sign chart represents the positivity of the function. So is it positive or negative? So we have positive, 0, negative, 0, positive. So that means it goes from positive to negative to positive, and these are my x-intercepts. The middle of the sign chart represents the change in positivity, so it's just this little graph look here. It almost looks like a number line. And then we're going to put lines here to represent the x-intercepts. And the bottom represents the values. So where did these occur? So maybe I have an x-intercept at 1 and 3. So it was positive until it hit 1. Then it crossed and went negative. And then it crossed again here at 3 and then went back positive. So that's what this sign chart is telling me. So how do I create a sign chart from the information that I have on this? Well, I know that it's going to change 3 times. So it has an x-intercept here and then an asymptote here that's going to change things and then another x-intercept. So I'm going to go ahead and put these values in. So at -4, -2, and -1, that's where things change. So I was negative to start. So that negative goes here. Then it turned positive. So I put a positive here. Then on the other side of -2, I started negative and then turned positive. So it goes just like this. So this would be the sign chart that represents this. Now multiplying functions. So it says that we're using f of g is equal to 2x plus 3 times 2x minus 2. So we should notice that there's 2 zeros here, right? So there's a number here that we can plug in for x that'll make this 0. And there's one here we can plug in and make it 0. So we should have 2 zeros. And then we're going to try sketching the graph of the function to determine the sign chart to use. We can always use Desmos to check our work. Now dividing is no different, but now we know we're going to have an asymptote here. So wherever this becomes 0, whatever we need to plug in for x to make this 0, that's going to create an asymptote. So we should have an asymptote there. And then we can try sketching the function and determine the sign chart. We can use Desmos to check our work for this as well. Now there's a video here that shows you how to use Desmos to create a sign chart. So you can go ahead and watch that video now. Let's take a look now at how to create a sign chart using Desmos. So we're given a graph here and we're told where it crosses and we need to create a sign chart. So first of all, we need to break this up and show where the roots are, where it changes and goes from positive to negative. So I can see that that's at 1 and 3. So I'm just going to go ahead and draw a line here and a line here. And I'm going to call this 1 and this 3. So all I did was write on it by clicking and holding it down and drawing my stuff in. So now I have 1 and 3. I know that at 1, I'm even. I'm not positive or negative. So I'm neither positive nor negative, so I'll put a 0 there. Now on the left side of 1, I am positive. I'm positive all the way up until I hit 1, so I'm going to put a plus sign here. Then between 1 and 3, I'm below the x-axis, so I'm going to call that negative. So this is negative, minus sign. And then on the right side of 3, I go back to being positive, so I put a plus sign. So this is how you can create a sign chart using Desmos. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. It's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the function sign charts assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click start the activity. The assignment begins with the learning goals and success criteria. We'll go ahead and click next. Now for this one, it gives us a sign chart for f of x equals 2x plus 3, and a sign chart for g of x is equal to 2x minus 2. So it says, what would be the sign chart for this one? Well, we know if we multiply these two that we're going to have roots at each of these points. So we know for our sign chart, we're going to have something at negative 3 halves. And at 1, just like here. Now we just need to figure out the direction. So we can use Desmos to help us with this. So we're just going to go ahead and enter this in. So we'll copy this and go to Desmos, and we'll put in y equals, and we'll paste that. And we can see that our roots are exactly where we said they were going to be, and it goes like this. So we'll go ahead and come back here and sketch our graph. Just like that. It doesn't have to be perfect, just something like that. And then we can see that we start positive on this side. Then at negative 3 halves, we're here, we cross at 0. And then we go negative. And then at 1, we're back at 0. And then we go back positive. So then we'll go ahead and click next. We're going to do that for each of these. So now we're going to figure out where the roots are. And the nice thing is they've already been plotted for you. So now you just need to graph them. If you need help graphing them, you can always use Desmos to check to see if you have it right. And we'll do that for each of these. Now, on this one, it says, what do you notice about the product of the roots? Well, we should know that the roots are the same. So the product of the two equations has the same roots. So we take both roots from each of them and put them together. Why do you think this happens? So you're going to state why you think that will happen. Do you think that will always happen? So you'll go ahead and state that there. Then we'll click next. Now we'll do it for the quotient of these. So we'll be dividing them. So you'll do the sign chart here and then plot the points. So hint, The roots still exist. Okay, so we now have one root, but the other one is going to become an asymptote. So we'll use that. We'll create our sign charts here. And then you'll use Desmos to graph them and see how this looks. And then sketch your graph here. So you'll do that for each of these. And then on slide 9, you're going to say, what do you notice about the roots? Well, one of the roots stays a root and one of them becomes an asymptote. Why do you think this happens? You'll go ahead and state that there. And then do you think this will always be true? Then when you're done with that, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.